Solving trigonometric equations basic, multiple angles. The directions say solve exactly the following equations over theta being greater than or equal to 0 degrees and less than or equal to 360. Okay. So I want tangent of 3 theta equal to 1. So I want to know what value of 3 theta, if I take the tangent, will make it equal to 1. So the tangent of 45 degrees is 1, so I know that's an angle. And the tangent of 225 degrees is 1. But since this is 3 theta, there's going to be more angles than this, so I can go from 0 to 360. So I'm going to add 360 to that, and to that, and that's 2 more. And then I'm going to add 360 again to each. And now I have 6 angles. Since there were 2 initial angles and there was a 3 theta, I'm going to times 2 times 3 and get 6. That gives me my 6 angles. Okay, now I'm going to divide each of those by 3. And that gives you your 6 answers. If you substitute each of those angles into my equation, tan of 3 theta equals 1, it would give you, it would solve the equation, give you the right answer. Alright, so now sine of 4 theta equals square root of 3 over 2. So I said 4 theta equal to, now I need to know the angles where I get square root of 3 over 2 for the sine. So that'd be 60 and 120 degrees from a unit circle. Alright, now I'm going to add 360 to those. 420, 780, 1140. I'm going to do the 120, so I add 360, I get 480, 840, and 1200. And again, I had 2 initial angles, 60 and 120, and I know I have to times by 4 to get 8 angles. So I'm going to divide each of those by 4. I get 15 degrees, 30 degrees, 105 degrees, 120 degrees, 195 degrees, 210 degrees, 285 degrees, and 300 degrees. Now notice that all those values are between 0 and 360. Okay, now we're going to try 2 more problems. Okay, so I want the cosecant of 3 theta equals square root of 2. Well, I don't know what values are really for the cosecant, but I know if I take the reciprocal, I get sine of 3 theta equals square root of 2 over 2. Because the reciprocal of cosecant is the sine, and the reciprocal of square root of 2 is root 2 over 2. So now I need to know, where is the sine root 2 over 2? Well, that's true at pi over 4 and 3 pi over 4. But I need 4 more angles because I have to get up to 6. So I add 2 pi and I get 9 pi over 4 and 11 pi over 4. And I add 2 pi again, I get 17 pi over 4 and 19 pi over 4. I add 2 pi to pi over 4, get 9 over 4, and then I add 2 pi again, I get 17 over 4. And then I add 2 pi to 3 pi over 4, and get 11 pi over 4, then I add 2 pi again, and get 19 pi over 4. 6 angles. So now I divide by theta, I get divide by 3, get pi over 12, pi over 4, 3 over 4, 11 pi over 12, 17 pi over 12, and 19 pi over 12. And those angles all will solve that equation. Alright, letter B. So cosine of 2 theta equals negative a half. Well, where's that true? When 2 theta equals 2 pi over 3, 4 pi over 3, and I add 2 pi to that, get 8 over 3, and 10 over 3 pi. Divide by 2, I get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And all 4 of those values solve the equation. Okay, let's look at another couple. Alright, problem 3, sine of 5 theta equals negative half. Well, That's true at 7 pi over 6 and 11 pi over 6. That means, now here I want all the answers over the real numbers. That means in radians, okay? Whenever you see over the real numbers, that means in radians. So radians are real numbers. Okay, so 5 theta equals 7 pi over 6 plus 2 pi n, and 5 theta equals 11 pi over 6 plus 2 pi n. The 2 pi n will give you all the angles because you rotate a full 360 degrees or one full revolution when you go 2 pi. So now I divide by 5, I get 7 pi over 30 plus 2 pi n over 5. Or I get 11 pi over 30 plus 2 pi n over 5. Okay, another one. I'm going to subtract 4, so I get tangent of 3 theta equals -1. So that means 3 theta equals, let's see, tangent's -1 in quadrant 2 and quadrant 4. So I got those angles. And so I set those equal to 3 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n. And then I noticed something. To go to that angle is just plus pi. So I could go 3 theta equals 3 pi over 4 plus pi n. So that means theta equals pi over 4 plus pi n over 3. Okay, so the video is a little bit long, but why don't you try this problem and we'll look at the answer together in class.